The topic that we'll have a look at now is correlation. What correlation does is, if we have two quantitative variables, it measures the strength and direction of the linear relationship between them. So if two quantitative variables are linearly related, a scatter plot of variables should show the observations roughly follow the direction of a straight diagonal line. The formula to calculate the correlation will look like this. So correlation is denoted by small r. The top line reads as the sum of I equals 1 to n of xi minus x bar multiplied by yi minus y bar. This is all divided by n minus 1 multiplied by sx sy, where n is the number of observations. If we remember from before, x bar represents the sample mean of our first quantitative variable x, and sx represents the sample standard deviation of variable x. Y bar represents the sample mean of our second quantitative variable y, and sy is the sample standard deviation of y. Before we have a look at any examples, we need to be aware of the properties of correlation. Firstly, the value for our correlation will always lie between plus or minus 1. So if you get anything outside of these values, you know you've made a mistake. If our correlation works out to be 0 or close to 0, then this indicates to us that there is no linear relationship between our variables. I've highlighted the word linear here, as it would be incorrect to say that the two variables have no relationship. We must say there is no linear relationship between the two. This is because there could be some other form of relationship between them, but by calculating the correlation, we are only testing for a linear relationship. If r is greater than 0, then the linear relationship is said to be positive. If r is less than 0, then the linear relationship is said to be negative. If our correlation value works out to be exactly 1, then this means that our two variables have a perfect positive linear relationship. If we get a value of exactly minus 1, then our variables have a perfect negative linear relationship. So if we have our two quantitative variables and we produce a scatter plot of them, we can get a general idea from that as to whether there is any linear relationship between the two. So we'll have a look at some scatter plots and talk through what they tell us about the correlation. Here we have y versus x, and we can see that our observations have produced a perfectly straight increasing diagonal line. This plot shows what a perfect positive linear relationship looks like, which means that our correlation value equals 1. Next we have a scatter plot of y versus x, and we can see that this time our observations have produced a perfectly straight decreasing straight line. This is what a perfect negative linear relationship looks like, and is represented by a correlation value of minus 1. So from the scatter plot we have here, we can see that our observations seem to fall randomly without any increasing or decreasing straight line pattern. Because there is no apparent increasing or decreasing pattern, we can say that there is no evidence of a linear relationship between the two variables. From the values I used in this plot, I calculated the correlation value, and I'll work through how to do that in the next few slides, but the value I got for these observations was minus 0.069. Although this value is not exactly 0, it is very close to 0, which says to us that there is little or no linear relationship between our two variables. In the scatter plot we have here, we can see that the observations do not fall in an exact straight line pattern, but there does appear to be a roughly increasing straight line pattern. This indicates to us that there is a positive linear relationship between the two values. The correlation value that I calculated for this data was 0.959, which is very close to 1, which indicates a strong positive linear relationship. In our last plot, again we can see that our observations do not fall in an exact straight line pattern, but there is a roughly decreasing straight line pattern present. What this tells us is that our two variables have a negative linear relationship. The correlation value of minus 0.952 indicates a strong negative linear relationship.